So this method I term as uncrisscross to find charges. You will occasionally need to uncrisscross a compound to say what was the charge of that cation or anion, because you need to know that to name it. So let's try it. This is uncrisscross to find your charges. So let's look at a compound real quick. I'll just write one that we didn't use last time. So let's use something a little bit easier first. What should we use? Phosphide? I agree. Let's use PB3, P2. PB3, P2. What you notice is PB is lead, P is phosphide. So you have lead and phosphide. Okay? The problem is you don't know the charge. So this is called lead phosphide. But you don't know what goes in the parentheses. So here's how you do it. This is called uncrisscross. If you think about the crisscross method where we kind of took the charges and went down, we're going to do this very similar, okay? And usually it's going to work out, but not all the time. And I'll show you a couple examples where it will and won't work out. One way to do this, and this is where it sometimes will work out, go backwards. Go backwards. Okay? And what I mean by this is this 3 charge came from here. So we know the phosphorus had that 3 charge. Okay, the phosphorus had a 3 negative charge. The lead had a 2 charge because that 2 came up. Okay? And I know that's 2 plus because the first atom is always going to be the positive charge. The second atom is always the negative charge. So positive, negative, okay? 2 plus, 3 minus. Now, we need to make sure this is true before we write it. To make sure this is true, you need to look at what you know. And you know, because you know the ions of nonmetals, all of these over here. Sorry, I can't see it very well. All of these over here. You also know the charges of these, right? Okay, these are the only ones that have multiple charges. So if you know the charge of phosphorus, and if it is indeed 3 minus, then this is correct. So is phosphorus 3 negative? Well, yes it is. Okay, we always know phosphorus is 3 negative. So therefore, lead is going to be lead 2. It's going to be lead 2. Okay? Lead 2 phosphide. Done. Sometimes it's that simple. Just to go backwards, just like that. That's called uncrisscross to find charges. Now, let's go through another example. It's not going to be quite as easy. Let's use NiO. This is nickel and oxygen, so oxygen would change to oxide. So we would call this nickel oxide. Almost lost it. So this is titled nickel oxide. The thing that we don't know is we don't know the charge in the parentheses. Okay? To find this charge, let's try uncrisscross, see if it works. If it does, I'm going to show you another method. Okay? Either method is fine, as long as you understand why it doesn't work. So, if we uncrisscross, both of these are 1. We know they're 1s because they aren't listed there. Okay? So when we uncrisscross, we're going to get nickel with a 1 plus charge and oxygen with a 1 minus charge. Now, is this true? Let's check. We don't always know nickel, but we do know oxygen. Okay? We do know oxygen. Okay? So, oxygen is not always going to have a 1 negative charge. Indeed, it never has a 1 negative charge. Oxygen, if you look at it, will always have a 2 negative charge. Okay? So, This says it has a 1 negative charge. So that means that this must not work. This strategy did not work to find it. Okay, if you're familiar, you could double it. That will usually work. So 1 times 2 is 2. Does oxygen have a 2 negative charge? Yes. So therefore, we must double this. 1 times 2 is 2. Does nickel then would have a 2 plus charge? Okay? Let me show you one more additional way though, because sometimes that multiplying gets confusing in the steps and that sort of thing. Let me show you another way. And this is kind of how I want you to strategically look at this. You have 1 nickel and 1 oxygen. Okay? So I'm just going to write how many atoms of each I have. And I'm going to try this technique here in a second for a slightly more complicated one. But you know that oxygen is always 2 minus. So you need to write that. So the total charge of your negative ions is 2 negative. So because it's a neutral atom, because there is no charge for this compound, then the positively charged ions must add up to 2 positive. Well, since we only have 1 atom here, what's the charge of this 1 atom? It must be 2 positive. Okay, so we have nickel 2, because inside the parentheses goes the charge, oxide. Okay, now we're going to try another one, slightly harder. We're going to get a little bit harder and harder. I'll try a couple more for you guys. Okay, but we're going to use this technique. See if you guys like this. Sometimes it's as simple as uncrisscrossing. But when you see that that nonmetal is not that charge, you have to try something new. So we're going to try PbO2. I'm going to erase this. Pb is lead. Oxygen is oxide. So we still are missing the parentheses. So let's find out this charge. Uncrisscross is not going to work. I'm going to show you why. Here, I'll just show it to you so you understand why. If you uncrisscross it, the 1 goes for oxygen. Is oxygen ever going to be -1? No, it won't. It's always going to be 2 negative. Okay? So that's why it doesn't work, because when you try it like that, it's not going to be happy. So let's try the technique we just used. We have 2 oxygens, so I'm going to put 2 oxygens and 1 lead. Okay? Each oxygen, if you look at your periodic table, has a charge of 2 negative. Has a charge of 2 negative. So each oxygen. So the question is, if each one has a 2 negative, what must be the charge of my lead? Well, the oxygens all add up to a -4 charge. So that means that all of my positive charges must add up to +4. Because once again, the atom is neutral. Are you ever going to have an atom that's not neutral right now? No, you won't. I can give you one later as a trick, but typically you're not going to have one. So, -4 for total for oxygen. So therefore, all your positives must add up to +4. Well, luckily, you only have 1 atom, lead. So, lead is going to be +4. Okay? And that's it. That's not too bad. So, let's try one more example to get you guys into the practice of it. This is copper phosphide. I'm going to tell you the charge here in a minute when we figure out. Uncrisscrossing in this case might actually work, but I do want to show you the longer technique as well. So in this case we have one phosphorus, and 3 coppers. Okay? So I just wrote them out like that. Each phosphorus, we know from this that phosphorus will have a 3 negative charge, since it's right there. So 3 negative charge for phosphorus, and each copper is going to have some charge to it. Let's figure that out. The total negative charge, 3 negative. So therefore the total positive charge is 3 positive. Well, that's weird. We have 3 coppers and the total charge is 3 positive. So what must each copper charge be? 3 coppers, total charge of 3 positive. Each copper must be a +1 charge. So when you write this, each copper is +1, but you do have 3 of them, just so you know. Okay? So what goes in the parentheses is the charge, not the number of atoms, but the charge of one cation. So the charge is +1. So therefore, this is copper 1 phosphide. Copper 1 phosphide. So, a couple things. If you struggled in this segment understanding where I'm getting the charges from, you need to look at the ions video and make sure that you understand where the phosphorus is coming from and all that information. Okay? If you struggle with the crisscross during this video, I know it's uncrisscross, but if you struggle with the crisscross, look at the crisscross video. And if you struggle with figuring out why it's oxide and phosphide and stuff like that, please look at the naming simple binary or the previous lecture, the transition metals.